Alright, so this time we have some natural logs and some e's. Okay, so this we're going to just go back to our four-step process. The first thing is to identify the u. So now we have to think about, well, what do we want to make the u, because I don't really see something inside of something else here in this case. Well, you want to think about, if you take one thing and do a derivative, will you be able to cancel out the other one? So actually what I want to do is I want to let the u equal natural log of x, and the reason why is because the derivative of natural log is a 1 over x, and when I solve, that x is going to cancel out the one that's there. So for step number 2, I'll show you what I mean here. When we take the derivative of both sides, you get du is equal to 1 over x dx. So for step 3, when I want to solve for dx, I'm just going to multiply both sides by x, so I get x du there is going to be my dx. So when I go back to the original problem here, I have 1 over x, and I have an ln x is going to turn into a u down below there, because that's what we mentioned was our substitution for ln. And then instead of the dx here, I'm going to replace it with x times du. Okay, so that all goes in here. So because of that, now I can get the x's to cancel out, and I end up with a 1 over u du left over. Now I'm ready to integrate in step number 4. Remember, if you integrate 1 over u, you're going to get 1 over absolute value, or you'll get natural log of the absolute value of u. So this 1 over u turns into the natural log there. So now at this point, what I'll do is plug my u back in. The u is natural log also. So what does that look like? You're going to have natural log of the natural log of x right there. Okay. So the u was just ln x, so that's why that's an x inside, not a u. Then that's going to be from e to e squared. So this is not multiplication. I'm not taking ln times ln. I'm taking natural log of a natural log. So we got to be careful when we put our numbers in there to get the answer. So first, you put in the top number. So I have natural log of the natural log of e squared inside there, minus the natural log of the natural log of e. Okay, so we have to just remember how we calculate these from pre-calc. Now what you can do there is use some properties. Anytime you see natural log of e, that's going to cancel out. It's really a 1. The 2 can come down in front of that. So really I have 2 times a 1 inside. So this is going to turn into just natural log of 2. I don't need the absolute values because I know absolute value of 2 is 2. So that's how all that works. So again, I'll just show that up here, what I did. The square here can come down front like that. And then the natural log of e turns into a 1. And if I have absolute value, that's why it just turns into a 2. So that took care of the inside natural log, but I still have the 1 on the outside. Now for this one, I'm going to do the same similar thing, except that this time I'm going to get a 1 inside here, because natural log of e is 1. Absolute value of that is also going to be 1. Okay. Now these are not like terms. I can't do ln2 minus ln1 equals ln1. However, there is an identity I can use for this one. Natural log of 1 is 0. So therefore, my final is because this part here, this part again that's going to turn into a 0 there. So therefore, your final answer is just going to be natural log of 2. So you can leave your answer like that. You don't need to turn it into a decimal. It's actually better in this form because it's more exact. So that would be the numerical value for that integral. It would be natural log of 2.